All right, I see people joined. Welcome, everyone. Probably someone else can join later. My name is Sasha. I'm CTO of Gravitational. Hey, this is me. Today I'm going to tell you everything Gravitational has learned while helping out customers to go on premises. And this is structured as the guide that we actually have in the form of this presentation webinar. In addition to that, we have this guide in the printed form, and we can send you out the PDFs after this webinar. So thanks for joining. I have several tabs opened, which I will need today. They are my whiteboard, which I'm just using to demonstrate certain concepts that we have onboarded. There are different application software and documentation that I wanted to show you to showcase certain features or certain solutions that we have found to be useful. In addition to I have this small demo of Telecube installed, which I will be clicking around mostly to show you very high level of what Telecube does and how it helps us to solve different problems for our customers. All right, let's get it going. Before we dive into Telecube and on-prem deployments, I'm going to tell a little bit more about Gravitational. Gravitational helps companies to deploy and manage complex applications across distributed infrastructure. Usually that means two things. First of all, we have to help our customers to package the application in the consistent manner and to deploy it to remote infrastructure, which is the topic of today's conversation. And the product that we have developed over these years that helps us to do so is called Telecube. And the second part of this is helping customers to manage this application, especially if it's a complex app consisting of multiple components after it has been installed. And management means that we have to securely access this application, or customers have to securely access this application. And that's the product that helps us do that. It's called Teleport. You can check it out on your own. It's our replacement for SSH for highly regulated environments that need very sophisticated access patterns or very restricted access patterns. All right, so that's about Gravitational. And I split this webinar into several sections that are basically mirroring the guide that we wrote, and we will distribute it after the webinar. First of all, it talks about lifecycle management and operations. Then we're going to discuss how are we managing release and upgrade cycles, or what are the best patterns to manage upgrade cycles, what not to do, what we usually seen in the past, creating problems for customers. Several aspects of going to production on the adoption curve of your application delivered on premises, probably several months to a year, actually, you will be deploying in POC, and then you will have this ramp up to go to production. So these are the steps that I will tell about today that we've seen to be really helpful when getting production-ready deployments of your application. And then the last one, if we'll have some time, I'll talk about managing organizational issues, problems that we have seen. All right, so let's go to lifecycle management operations. Before we talk about the actual operations, we can think about why would you need to go on-prem in the first place. And usually there are two significant driving forces behind going on-prem from SaaS-style deployments. First of all, it could be security and regulations. There is some sensitive information that by definition cannot leave customers' infrastructure, and this infrastructure could be a private Amazon account, or it could be VPC logged in, or VPS, or some sort of managed colo environment. The other driving force is data locality and latency. For example, if you have a data analysis solution that crunches a lot of information at the same time, it doesn't make sense to offload this work to the cloud, because the transfer will take a lot of time. Or if it's some sort of network proxy or network intelligence layer, it actually makes sense to have it as local to the data, as local to the workflow. So after we will share some challenges we've seen so far, and the first one is called deployment fragmentation. This one is the most common, and basically with the deployment fragmentation, in addition to existing hosted offering, you will result in at least two different ways to deploy the application. Usually this leads in bifurcation of team responsibilities, doubling the work. We've seen that results in having two different teams. The first team takes care of the cloud deployment, and the other team takes care of on-premise deployment. it also creates this team tension that we will talk about. But the good solution is to unify deployments by migrating to Kubernetes as the primary platform for both deployments. The Kubernetes, if you are not familiar with Kubernetes, Kubernetes is a deployment platform that abstracts away the details of the underlying infrastructure and gives you the consistent layer, the thing we call bubble of consistency that you can rely on to deploy your application. It's really important, though, to make sure that your on-prem team is not the only team that onboards Kubernetes, but the Kubernetes is deployed consistently both on the cloud and on-prem environments. Okay, so let's say you migrated to Kubernetes or a similar platform. So Kubernetes is not the only one out there. The one that Telecube is focusing mostly is Kubernetes, but there are others in the market. So what are the other challenges you will encounter after migrating to Kubernetes? The second one is this deployment fragmentation and installation complexity is the second one that you will hit. To deploy Kubernetes and all its components usually takes about 15 to 20 steps at minimum, and that creates a lot of problems because your installation guide that you will send to your teams or your customers will consist of a really big Google document that will, the more steps you have in your document, the more chances your customers will misread it or miss the step in the installation. So your perfect scenario in this case to avoid deployment fragmentation and simplify installation complexity is to bring the whole installation step of the whole application to just one command. With Telecube, I just wanted to show you how Telecube solves this problem. If we go to our documentation, the whole installation, we brought it down to just one step that is called install. Telecube packages your application, all its dependencies, all Kubernetes dependencies, etcd, Docker, and everything that needs to be run, including your Docker images, in one single tarball. After this tarball can be installed or distributed the way that makes sense to your application, your company, it could be distributed, and we'll talk about the distribution part a little bit later, but after it's on customers' air-gapped on-prem environment, there's just one command they need to learn, which is called gravity install on the first node and gravity join on other nodes. The interesting part of this system is that we not only install all dependencies of Kubernetes, we install your application on top of that right after. So from the user's perspective, they don't actually need to know that there's Kubernetes, etcd, Docker, all this complexity involved. All they see is just one liner that they have to learn and install and distribute and communicate to their team. We found this really helpful to solve this deployment fragmentation and installation complexity. All right, let's go back to the other steps. The other big challenge is handling incompatible resources. When we deploy, or you will start deploying on premises, this is actually really hard problem to solve because not only there is the deployment fragmentation in the form of different operating systems, different kernel versions, different hard disk drives, different networking setups that is out there, you will have to be aware of all of them, and you'll have to deal with hardware that is always and sometimes incompatible with requirements of your application. This can cause, in our experience, hours of troubleshooting, and it will be unclear to you why the installation has failed. Did it fail because your installation script did something wrong, or it failed because the disk is slow? So Telecube helps to solve this problem with our application manifest. What we're trying to do here with this application manifest, we're trying to define your application as precisely as possible. And in addition to defining the properties of application, we're providing requirements for your application. So let me give you an example. We have this notion of flavors, and a flavor basically sets up the requirements of your application in the sense of, hey, this is the worker node, and it's supposed to perform CPU-intensive operation. That's why it has to have a lot of CPU and RAM, for example. And this is my database node, and because I want to deploy Postgres there, and this Postgres node has to have a really fast disk. And by the way, there should be a really fast link between my Postgres node and my worker nodes, just because we know there's a lot of requests going back and forward. How do you define this and how do you communicate these requirements to customer? If it's just a document, there's a really high chance that we'll misread it, that will ignore some certain parts of the requirements. So the only reasonable way to solve this problem is actually communicate these requirements through code. We do this by specifying these requirements for every single node you're installing on, this node has a notion of flavor, saying the database node, for example, in this case, has a requirement to have minimum 8 CPUs, minimum 32 gigs of RAM. You always list the operating systems that you wish to support, and we'll talk about OS a little bit later. In addition to that, if it's a disk node, if you need some disk from the host, you explicitly tell customer cells, let's say, hey, we need at least 512 gigabytes of capacity. We only support those file system types. And by the way, there should be minimum transfer rate between my application and the disk. That's the only way. Hey everyone, sorry, there was a glitch and I was disconnected. Do you hear me now? All right, cool. I'm back. Sorry, that was a glitch. Let me continue share the screen and we will return back. All right, so we talked about this capacity volume requirements last time and how Telekube verifies these requirements. During the first installation step, we execute those pre-checks. The installer, before even starting the installation, make sure that those requirements can be satisfied with every node. And in addition to that, we give this opportunity for your service teams to go with this checker and make sure that they can run the check on the customer's infrastructure even before starting the requirements. For example, even as a part of pre-POC step, they can take this manifest, take the binary, and before packaging anything, they can just run this pre-checker, and it will run these checks for you and tell them, hey, actually, there's not enough disk, there's not enough disk space, there's not enough network, and things like that. So we found this to be a really, really significant help to battle this problem of handling incompatible resources. The other problem is actually even bigger than an installation problem. It's called handling installation complexity. And installation complexity upgrade complexity. Installation complexity kicks in the POCs, and usually it can be solved fairly with low friction compared to upgrade complexity. Once you are in production, you need to have the way to consistently and reliably upgrade the application on bare metal infrastructure, where there are two important properties to keep. The upgrade has to be usually in place because many customers don't have spare bare metal resources to go cloud style, kind of spin up the second environment and run it there. And during this in-place upgrade, the system has to be fully functioning. It means that you cannot fail, or even if you fail, the system cannot go down. Telekube with Gravitation will spend lots of time trying to solve this particular problem, and we can tell you it took us around almost 3 years to figure this out. Here's how we solve this problem. We split the upgrade operation into phases. These phases by default are not visible to users. However, every phase includes as isolated step of the upgrade of your infrastructure as possible. Before running the upgrade, usually developers or service team that part of your engagement with the customer runs the plan so they can make sure that the upgrade operation consists of the step they expect. For example, if we ship the new version of Kubernetes with Telekube, the upgrade plan will list you the exact steps that we'll be taking to upgrade Kubernetes first. If you only ship the application as the part of this tarball that we package and distribute, it means that the Gravity plan will show you only one step that will consist of upgrading your Kubernetes resources, for example. We found this really instrumental and really important to solve the problem of upgrade complexity. I can tell you the first naive way several years ago that we approached this problem was to handle this self-hosted or single-step upgrade that was visible and was not expecting everything to succeed, and then try to roll back. Well, in practice, that didn't work because by default, if upgrade is successful, great. But if upgrade failed at any given moment of time, you have to have a really solid plan of how do you solve that particular issue? How do you retry every single individual step? And moreover, your customers would not know anything about Kubernetes or anything about etcd, so the upgrade should be smart enough to retry only the upgrade phases that were failed or didn't succeed. So that's the. However, this is an example of this upgrade step that we implement. So let's look into what's happening there. first of all, we initialize the upgrade operation. We bootstrap the operation. Then we go node by node and execute the upgrade procedure on the nodes that we elected as masters. Then we execute the runtime, and then we execute the application in this case. However, these phases are usually hidden from the user, so everything they see is just one step, gravity upgrade. So it's still a very simple upgrade procedure that they don't need to know anything about. There's only one command for them to learn. However, if this upgrade procedure fails, we still go back to this multi-phase system that your services teams are educated about, and they can retry the phase that has failed. They can communicate the phase of the upgrade procedure that has failed to the development team, and they can retry the phase after figuring out what actually failed. And by the way, the upgrade failure may not necessarily happen because of something wrong that you have done. Actually, majority of upgrade failures that we have seen have nothing to do with your application or Kubernetes or etcd. Majority of them are caused by network outages, by slow storage attached network on the customer's infrastructure, by spontaneous reboots, or by some power outages on data centers, data corruption that happens during upgrade on some disks. So those things are out of your control. That's why it's really important to have a really solid foundation for having always an ability to continue with upgrade, to roll back to certain stages, and execute this on every single step of the this upgrade procedure. By the way, if you have any questions, you're welcome to ask them in chat window. I'll be periodically checking here, and if someone asks me, you can ask them the question anonymously, or and I will try to answer it here during the Q&A session, or if I see something, if you have a question in the middle of this, some topic, feel free to follow up with me as well. All right, so I spent so much time talking about upgrade complexity just because this is the problem that consumed probably 80% of our time at Gravitational. When we deployment something is a really easy step compared to managing consistently upgrades. And what's more important is to have this expectation with the customer that at any given moment of time, the upgrades are not very risky for them because the system will continue running. And if they have this ease of mind when running the upgrade, they will be promoted to run, and they will be empowered to run the upgrades on their own to reduce the pressure of your services teams, and they will be empowered to run the upgrades faster on a faster schedule, which the topic that we'll cover later. So check out the gravitational upgrade procedure, and if you're looking at, for example, doing it yourself, also ask yourself a question, okay, what is my upgrade plan? What is my kind of backup plan in case of something failed? What parts of the system can fail during my upgrade? And how do I communicate this to my services teams and to my customers as well? So what is exactly that they should do if this thing fails? Another interesting topic is handling application upgrade failures. So Telecube does its best to help you out to manage failures of the upgrades of etcd, for example, or failures of upgrades of Kubernetes, for example, and allowing you to continue from this step. But what to do with your application, how to make sure, even if the platform upgrades successfully, what should be done to make sure application is upgradable and it doesn't fail all the time. So if your application upgrade is structured as a monolith, so you have only one upgrade step, you will have exactly the same problems that Telecube had in the original version of it, saying that if you are not clear what step of the upgrade has failed, you have no visibility and customers have no visibility. It means that it's really hard for you to help customer solve the upgrade failure or retry the upgrade failure. So there are a couple of tips and that we help our customers with when we engage with the services, implementation services with them. And I want to list a couple of those that we have found the most useful. So during the upgrade process, we strongly advise to take automatic backups. So before the upgrade, make sure you use Gravity Backup. In case of using Telecube, we have this special hook that you can implement your own backup in our application hook structure. So this is just a Kubernetes hook that you can implement, a Kubernetes job saying, hey, I want to back up my application. One of them, it's connected to our backup and restore. It takes the backup and snapshot of your app. You should educate your customers to take this backup with a Gravity Backup command, automatically or manually. Better, automatically is of course better. So in addition to that, you should run migration as a separate process. One of the biggest problems we've seen during the upgrade process is the database migration. And many teams start with running upgrades as a part of their installation step or as the part of the spinning up an individual service. So for example, if you have a service, 5 different services, and every service talks to the database, it's really tempting for developers to implement a migration procedure as the part of the service startup. Actually, especially if it's Node.js, they have the gulp, really handy kind of hooks that they can add, and every time service starts, it tries to execute the migration process. We advise against this for one simple reason. Imagine you have 5 different services, every service starts up, and they start executing the migrate procedure. What if there is live traffic to your application? How would your application react during the live upgrade procedure? It is highly unlikely that your migrate procedure will not be disruptive for your application, especially during schema changes. By migrate procedure, I mean, for example, changing the schema in Postgres dramatically, but your application old version will not be aware of that and can start failing spontaneously, showing some errors in front of the customer, which will raise an S1 support ticket with your services team. So instead, we suggest strongly that you separate the upgrade process as a separate step that is isolated from the services startup. There's a really simple way to do that. Let me go to the whiteboard real quick. So this is my digital whiteboard that I'll be using to demo it. So for example, one good way to do this with Kubernetes and Telecube is during the upgrade process. It's a really easy way to do this. Switch the traffic of your web app to landing page. And this could be done with Kubernetes Ingress Controller or Nginx. It means that this landing page that your customers will see will mean that there will be no production write traffic going to your databases. So let's say you've got Postgres or any other database, like Mongo, for example, here. Your job here is to make sure there's no production traffic, no writes basically are happening. Because if the writes are happening during the schema migration, it makes your job way more complex than it should be. Because not only you have to keep track of 2 different versions of your schema during the writes, there could be, for example, old service that is not aware, trying to write something to your old version, and there could be a new version that is doing the migration. Some databases make this slightly easier, like Postgres. Some databases have no idea about the migration step, and you'll just get lots of error. By switching the traffic of your user, for example, through get or open the browser to the landing page, you're draining off your writes. After you have drained off your writes, you can start safely this individual step of the migration. So now you can kick off the Kubernetes migration job. And it doesn't necessarily have to be Kubernetes. In case of Telecube, it's a Kubernetes job, or you can have like a simple Ansible in case it's not Telecube or something else, or not Kubernetes. The important thing is there's no writes. Kubernetes migration job is going on. After the migration step, you want to run smoke tests, as we call, you can take the backup of the data before the migration, drain off, take all precautionary steps to make sure after the migration the application is running. Check the migration is run safe by running what we call sanity tests, very simple tests that are application specific, and try to make sure everything is working. Or smoke tests, the tests that are running continuously inside the cluster, which is the topic that we will cover a little bit later. And then after that, you're switching back. So you're going back, and from the landing page, you're going back to your Nginx pass-through. And Nginx here is an example. You can use Kubernetes Ingress service for that. You can use Nginx as a plugin to Kubernetes or any other load balancer that makes sense to you. That's a different topic for conversation, but after that you can pass through all the writes from your application back to your database. They're different. This is not the only way to solve application upgrade problem. However, there are more involved way that do not include this downtime and landing page approach. However, in our practice, this is the easiest, the simplest way that many customers are comfortable with, because they're okay doing with the partial degradation of the application for 30 minutes while the upgrade is running, as long as they don't get inconsistent data, and they can always go back consistently to the result back. If you need a more complicated upgrade procedure, we help customers to implement a more complex one that doesn't include any downtime, but that's really already an improvement over this pretty solid solution. All right, so that's the application upgrade failures. Another problem is creating consistent application environments. Even though Kubernetes and Docker can abstract away infrastructure differences, that's why Telecube ships with Docker and Kubernetes. The problem is that imagine you deploy Docker and Kubernetes on your own, or you simply told, hey, customer, why don't you deploy Docker and Kubernetes, and we will just deploy on top of this. This sounds really compelling, as a really compelling options. However, in practice, that didn't work for us, and probably you will encounter certain problems with this as well. Here's some of them. Imagine you have Docker's great, but Docker has 4 or 5 different storage engines that it relies on. Every storage engine on Docker behaves slightly different based on the type of the file system it works on. Kubernetes has several network plugins it supports, and every network plugin provides different requirements to the underlying infrastructure. To give you a couple of practical examples of how Docker and Kubernetes itself can be fragmented, storage engine is one example. In Kubernetes, you can have a couple of CNI plugins, so-called network plugins, and one of them could be VXLAN, and another one could be, let's say, Calico. And we don't need to know anything about those 2 plugins except the fact that those network plugins have different requirements to the underlying infrastructure. For example, Calico will require a certain routing layout on your own customer's data center. If they have different network segments, you will have trouble understanding why there is network partition between them, especially if customer doesn't have any expertise or deep expertise in understanding the details of Calico deployment, but they just deployed it from the quick start guide. It means that now your services team has to be an expert in Calico deployments and routing deployments on bare metal and routing details and the switch types that your customers is deploying. VXLAN, on the other hand, has slightly different requirements. However, it's less demanding to your infrastructure, although it requires certain kernel versions. So these are just 2 examples. However, Kubernetes not only supports 2 different network options, it's actually, I think, if we go to the Kubernetes webpage, it supports 15 different options. So which one you should choose for Docker, which one you should choose for Kubernetes, and what is your guidance to communicate to user? Again, even if they go with Kubernetes and Docker, it doesn't mean that you won't get this fragmented infrastructure that you'll still have to debug. Telekube addresses this problem by being extremely prescriptive in how we deploy Kubernetes and Docker. We call this bubble of consistency. When Telekube is deployed, actually what we do, we not only ship Docker, we ship Kubernetes, and we ship all dependencies of Kubernetes, and we prescribe exactly what versions of Docker are supposed to work with certain versions of the operating system in our application manifest. In addition to that, we set up 1 networking plugin and not 10 networking plugins, and we pick the network plugin that is less demanding to customers' infrastructure, that provides a good way of abstraction for Kubernetes to do its overlay network, and does not create a huge operational overhead. All these factors considered, we picked VXLAN that we ship by default. It doesn't mean that we won't support anything else. It just means that if you don't know what to do, Telekube has it sorted out. There are a couple of reasons we picked VXLAN. For example, it doesn't need any significant knowledge about customers' network topology on bare metal infrastructure. VXLAN encapsulates network packets over UDP and sends them peer-to-peer style. It means that as long as 2 hosts can see each other, the networking will work. In addition to that, VXLAN is supported in all major enterprise distributions out there, CentOS, Red Hat, without any trouble. So your operational overhead and your risk of deploying something really strange or getting into really complex troubleshooting session are lower than otherwise. So that's actually the major difference between deploying on-prem and deploying on cloud, or even deploying in your own organization. The moment you deployed your application, essentially you have lost all the control over the infrastructure. You don't have access necessarily. Maybe the best way you can access your infrastructure is through the WebEx session. It means that everything that you deploy should be working in something we call submarine mode without your interaction for years. And that creates a completely different set of requirements to you being more conservative with your deployment than, for example, on your cloud. Because in the cloud, you can go with more interesting, more adventurous CNI plugins, something that can use BPF or new kernel extensions, things like that. And without those things, on bare metal, you have no of those options. And basically, without those things, Kubernetes will fall apart and you will not know why. Okay, so that's the consistent application environment. There's a lot of things to cover there, and everything we create is called a bubble of consistency that helps us to isolate these environments in a consistent way and to make sure they work fine. All right, so that's the second part. It's managing release and upgrade cycles. I still have a lot of material to show and to demo you if we'll have time. Although the one thing that you'll probably encounter is really long upgrade cycles. This problem is really paired with the fact that if your application upgrades are inconsistent, or they're consistent but they're really hard to do, and they require, let's say, 10, 15 steps, it means that your customers will be demotivated effectively to do the upgrade, because right now everything works for them. If they run an upgrade, they think about it, well, I'm running into this risky situation, and at the same time, I'm not sure what I'm getting back. In practice, if your application upgrades are not solid, it means that your customers will have your versions of your software as old as 1 year or 2 years. This creates a lot of friction because most of your development team already moved away from this application version of 2 years ago, and they have no idea and they don't remember what was there. Creates a lot of fragmentation, a lot of friction inside the team. So what is the solution? Well, actually the solution is to have really solid, really fast, really simple upgrades that you have tested really well, and push your customers to upgrade on a frequent schedule. For example, you can tell them that you will be pushing patch releases on a monthly schedule or even on a weekly schedule, but those patch releases should be really low risk and should be really fast. So then your customers will be motivated to do them real fast. Then you will do a little bit more involved upgrades as your minor upgrades, but they won't include any migrations, for example. So they will still be low risk, but then your development team can move faster, and they have reduced this bifurcation between what they have in the cloud and what they have on-prem. And then once in a while, once in 3 months, you will push the major upgrade that can include migrations and things like that. So keep in mind that your job is to reduce the upgrade cycle from, let's say, a year, the worst case scenario is 2 years we've seen in production, to 3 months. And that will be a huge win. If you can push even further to, let's say, a couple of weeks, that's great. But we haven't seen that in practice just because your customer's upgrade cycle usually is bound by their ability to execute as well. So you may be fast, but your customers may be not. That comes to release management and versioning. It is impossible to do the upgrades without communicating to your customers the risk associated with upgrades. So one of the ways to solve this problem is to use semantic versioning. And you can find the semver spec in the internet. Basically what it says is simple. If we go to the whiteboard real quick, we can say, okay, let's look at this application version 4.0.0. By itself, this 4.0.0 doesn't tell much. However, what is important is when you release 4.0.1, you can educate your customers that this is the patch release. What it means is that patch releases are not supposed to have anything except security fixes. Usually they don't have any migrations or anything risky, which means that when customer looks at 4.0.1 and your release in your software center, it means that it's low risk and they can upgrade today. Second, imagine your customer sees this 2.4.1. What it means is that generally 2.4.1 should be compatible to 4.0.1. However, it's a little bit more risky. It could involve some more significant deployment or changes in your application. However, it's considered to be a minor release. It can have some minor migrations as well that are not disruptive, but it shouldn't, for example, switch from one version of Postgres to another inside, because that's not what your customers expect. And then let's see as the change of this to be 5.2.1. So that communicates to me when I'm looking at the SEM version that if I want to go from 4.0.0 to 5.2.1, I'd better get ready. So I'd better check this with you to make sure what is my changelog, what am I getting into, and I'm going to test it on my staging several times. Of course, I should test ideally 4.1 as well, but this I cannot even deploy without taking significant, maybe a couple of weeks effort into that. So having this consistency across your releases is really helpful to communicate to your customers potential risks. So keep this in mind when thinking about releases and versioning. In addition to that, there's a packaging step that is also important. We advise to use Helm as a package manager on Kubernetes, and we also provide a way to package and release your application and have everything versioned as one application bundle with the same ver that is published on your S3 bucket or through our distribution center that is part of Telecube. So your customers can see all the versions available there, and they can download them on their own pace and install them on their own pace. So packaging and versioning is important. At the same time, publishing installable software is as important. So there are a couple of ways you can publish the software. One way, we've seen people do this through FTP, password-based application kind of download link. It doesn't create a lot of helpful user experience for customers. That's why we advise to implement an integrated download center where customers can log in and can see applications available there. And I think I can open one of the examples of the download centers that we have internally. And so what you want to give your customers a really good experience so they can log in with their SSO, go to the download portal, see all their releases, see their licenses available for them, and get the documentation. So this experience is really instrumental to give this really production look and feel to your application. Because if you don't have the central distribution endpoint, your customers will not know what's it out there, what is the changelog, what has changed, for example, what are the bug fixes that you have implemented and things like that. That's why we suggest use either thing that we call App Center internally that we communicate and distribute that is used to distribute application on your behalf, or implement something on your own, like even a simple web page with S3 buckets that has all change lists is really helpful for that. Okay. So now we're going to road to production. The really important part of going to production is actually the first thing every single customer of yours, significant customer, going post-POC step will ask you, hey, can you please give me the full license scan of all the dependencies of your application? I've seen this create internal chaos every time, especially if teams are not prepared to do that. And there's a lot of uncertainty about what should I do and how should I do this scan and what actually I should do with the scan, because it's not only challenging to understand the results of the scan, to get the results of the scan, but also to understand what the scan means. So we suggest to use something like Fossa.io. This is a really interesting company, friends of ours. We use them internally as well. What they do is they continuously scan your software every time you send pull requests. And you can see with every PR, understanding of what the licenses were added. With every license, then, you have to make a product manager or security or compliance officer in your team has to make a choice whether this license is good or not. And then usually when we see, there's a lot of confusion when people see GPL license, they panic because, oh man, that people don't know what GPL means usually, or do they have to get the lawyer? Do they have to remove these dependencies? Well, we're not definitely going to give you advice. Our advice is usually get a good lawyer. For example, there's a good lawyer company called Silicon Legal that Gravitational works with. There are many other interesting and good lawyers out there that help you with analysis of this licenses that your application has. However, in our experience, actually, we can tell you that having GPL license file in your software does not necessarily mean that now you have to open source everything with GPL. It only means that now you have to carefully look at how exactly your application uses the software. Does it link to it? Does it use it as a library? If it's LGPL, it could be LGPL with a certain clause that actually allows this as a library use without disclosing. And there's also license TLDR. I'll send you the link after that sort of explains you the main differences in a very simple way. That is actually this license TLDR is hosted by Fossa as well. So they help they help teams to understand this. So we're not affiliated with Fossa. You can use different scanners. The point is, have the scanner continuously at all times, and even before considering going to production, set up the scanner to run. Then the security audits is another important thing. We recommend to go with security audit even before you go to production, to have it on your hands, because pen test and audit, everything will be asked, especially the data scan, the data flow diagram. Usually the data flow diagram consists of all the bits and bytes your application is sending, what protocols are involved, what encryption is involved, And having a good pen test and data diagram in front of the customer, even during the POC, gives them a good sense of that you actually know what you're doing and they're ready. Most of the friction we have seen with security audits so far and pen tests is that when you send unencrypted traffic over the network, usually it's always a blocker. So make sure you're never sending the unencrypted traffic. In Telecube case, we tried real hard to make sure all control plane is always mutual TLS. All traffic is encrypted between each CD, between control plane nodes, between Gravity components, user interface panels, and things like that. So you should really, there are many compliance and audit firms out there. I have a couple of my favorite, which I can recommend. One of my favorite is Cure53. I'll send you the link. The reason I like them so much is because they do a lot of stuff in open source, and they don't hesitate to publish the results. So that's why they're not afraid to be accountable for their work. I think if we Cure53 Telecube scan is actually published online. The way I found them actually is through just looking for Delph open source pen test, and I found the Cure53 website, and this security team was sponsored by Mozilla to do open source scans for curl, for Dovecot, and they published everything online, which is awesome. And we did the same with Telecube. Once we pen tested Telecube version, we just published everything we found, and Cure53 provided this analysis. You don't necessarily need to publish your software pen test. Obviously, that's completely up to you, but to have one on a regular basis is really good. It gives your team assurance, it gives customer an assurance, so keep this in mind. So even before you engage, it's really good to pass the security audit, pen test, have network diagrams in front of you, so you always are equipped to answer those two questions. What are the licenses of your software? Please give me those, and pass security, and have you done your security audit, and how often do you do security audits? So with regards to that, there's also application security, right? In addition to security of the Telecube. That's why I always recommend to engage with someone who really knows what they're doing, help you pen test. In addition to that, every pen tester, you should really communicate them the details of why are they doing this pen test, so they can focus on things that matter to you. For example, if you involve a pen tester and just tell them, hey, please pen test my application, if your application is really big, they will start digging into code if it's a kind of white box style review, or they'll start digging into CSRF attacks. However, for on-prem, you should always give them the guidance. Hey, actually, we're going to deploy this on customer's infrastructure, and there are points that we want to be covered. For example, make sure you run network scan, and because that's what every single customer does. Once you run network scan, they will immediately show you the weak ciphers and weak network protocols that you're using. So you should kind of fix them as well beforehand, go into so not only it's important to engage with security auditor, but it's also important to give them the guidance on what to look for so they can focus and give you really good and honest review of your infrastructure that will help you a lot. So that's application security. There's also Kubernetes deployment security. I mentioned that we actually pen test, and our report is online. You can check it out. We try to do the same. We try to be transparent with what we do with Telecube, so we can use this as a part of your security audit to present this to customers as well, which gives a nice touch to it and helps it. In addition to that, actually, it's really important not only how you deploy and what do you deploy, but securing the cluster. Telecube comes in with section on securing deployment. It means that when we deployed Kubernetes, we went through that securing. We're trying to deploy Telecube cluster with a really kind of not very developer friendly, but very on-prem security friendly set of security policies. There is a very good CIS benchmark for Kubernetes that we'll always go through when we release it, and it always prescriptive of what can and cannot do with Kubernetes. For example, in Kubernetes 1, ideally you are disallowing privileged containers, and you don't need to know about what privileged containers are, but just keep in mind that Kubernetes has about, 50 different options that you can tweak on and off. So you should really pick ones, and Telecube tries to be really prescriptive in the options that it comes in, and it forces your application team to really think about security before actually deploying there. This is more less of a security, but that's a tip we have found of when we were deploying Telecube ourselves and helping out customers. If you do not offer and enforce evaluation licenses, it means that it's not that your customers are bad or somehow want to pirate your software. It means that very often they basically forget about the fact that they need to renew the license or go past POC license. And it always very often slips through the cracks, and it significantly increases the adoption curve of your software. So our recommendation is to create those evaluation licenses and ship them to the customer. The idea of evaluation license, if you go to Telecube documentation, there's a licensing section. You can generate the license in the application manifest. You can turn the license on, and you can say, okay, this license is valid for 3 nodes only. So you kind of disallow them to have large clusters on a POC license, so that will reduce the pressure on you. You also give them this end user license agreement that they have to agree on. And after a certain period of time, when the license is expired, you write a Telecube hook, which is listed here, which basically shuts down your application and says, hey, by the way, customer, POC license has been expired. And if you write this very easy, it doesn't have to be really secure, but it could be just shutdown hook, that one of those similar hooks like right here, that just, for example, turns off Nginx and shows this warning message. It highly motivates your POC customers to upgrade, because now for example, lead of DevOps or lead of infrastructure looking at this warning and say, oh, I have to talk to my procurement team soon. So that's less of a technology problem, but that's kind of technology problem that can be kind of human process problem that can be not solved completely, but kind of accelerated through usage of expiring and restricted licenses that you ship with your software. And so keep this in mind when you will be doing any POC engagement. This will really help your business to go past POCs faster and get this production contracts faster. There is also a big topic on HA database deployments, which I probably won't cover extensively today. Just keep in mind that deploying highly available databases is really hard without Kubernetes, with Kubernetes, on any bare metal environment. So our advice is actually, if you cannot deploy HA originally for databases and can just say, look, we've got this backup and restore, and my database is not HA, but you can always restore in a matter of minutes, that's usually a really good step to go forward. And after you go into HA mode, if customer says, no, I have to have a strict SLA, usually what we do, for example, with some of our customers, we help them to roll out highly available Postgres on top of Kubernetes. We train them, we train your customer, and we clearly communicate to them, hey, this is what you would expect. There's HA Postgres there. There's automated failover. But to be honest with you, this is a really complex and involved process. There is no magic deployment we have seen encountered so far that just magically works on any environment without any troubles. It means that your customers and you will have to have some experience in databases that you manage. So if you cannot do HA of Postgres or any other database and still ship reasonably available product using just consistent backup and restore procedure, please do. There's also simplifying the operations of Kubernetes step that I wanted to cover. It's basically saying that Telecube tries its best to operate Kubernetes really easily. To demonstrate this, we try to reduce the amount of steps customers needs to know about Kubernetes to 0. And that's why we have this Gravity install and Gravity upgrades. At the same time, we have invested so much in planning our upgrade procedures and educating your services teams and educating customers to what to do in case of things go wrong. So there's no magic bullet, but we try really hard to simplify the operations of Kubernetes. Failure recovery, as I showed in documentation, is also really important. So it's really important to have the easy, consistent runbook, to resume the upgrade, to roll back the upgrade. Actually, the notion of runbooks should be communicated to your customers before actually calling this a production. They should know, for example, how to remove the node without calling your support every time. They should know how to add the node, or how to recover the node, or how to back up and recover from failure if everything went down. So the more detail and the more information you give them, when preparing them to go to production, the better it is for you, because it will dramatically reduce the pressure on your services teams that won't have to do this education beforehand. And in addition to that, it will empower your customer and give them actually, we've seen that they're more confident when they know that they can do things with your cluster without talking to you all the time. It's a really good sense of control that will really help you. So there's kind of the initial force is just to give them this magic box that always works. This is really good for sales and POC, but past POC, it's really important to give them all details on your deployment and all these runbooks. You can take our runbooks, for example, and many customers do that, restyle them, refactor them, and just give them as your application as well. So you don't necessarily need to refer to Telecube all the time. You can just restyle the runbooks. The important point, you have to have runbooks on every scenario that you can potentially imagine out there. The monitoring step is a big one. To show you the monitoring, actually, I wanted to show you how Telecube does this. We try not to implement our own monitoring. In this case, Telecube packaged Mattermost, and it tried to become the single cluster with the Mattermost application. And what we do instead, we ship Grafana with your dashboards that customers can add on their own. We predefine certain dashboards, but actually the most important part is to give this consistent view of the dashboards that are always shipped with every single installation and educate your customers of what dashboards to look into. The dashboard that we created by default is really simple. It has this just Kubernetes health basically, but in reality what you want to have is to have your custom dashboard health, that the first thing when customer clicks here, they will see a couple of really important, the most important points of your application. Hey, is my app healthy? In addition to that, we allow you to integrate with the healthy health check endpoint that we periodically execute. So that's really important step to have this visibility and monitoring embedded in your deployment. And so it feels like it's just a part of your product. So every team can have their own dashboard, but you also ship this dashboard that cannot be modified by your customer. That is always the same with the same version. It gives this really professional look and feel to the whole deployment and really simplifies the deployment step. The same applies to metric and alerts. Telecube, by default, we integrate certain metrics and alerts on Kubernetes cluster. So for example, we will alert if there's high watermark on disk and CPU usage. However, the important step is to write your own alerts, and we have the whole section of alerts here called cluster monitoring section. We help you to write and plug in dashboards and alerts. By default, we use Capacitor. You don't have to use Capacitor stack. You can use Prometheus or anything you like. What is important is every cluster ships with its own version of dashboard and a certain version of alerts that make sense to your application. To give an example, if your application is degraded, customer expects an alert. If you're not sending this alert, if your application cannot talk to the database, it's not a good user experience for a customer. They will always come back to you and blame you for this. So what you should do, you should write an alert. In this case, it could be a Capacitor alert. Plug this into the installation procedure with Telecube, and then ship it to every customer and show them, hey, give me an email during the installation procedure of your ops team or PagerDuty, and this is the email we will integrate with Telecube. So there's one command to turn on this alert target, and Telecube cluster will alert you if my application or your application goes down, or Telecube will be degraded for a certain part. So that's a really important step. Integrated metric and alerts, both platform is important. Another interesting feature, so logging, status check, and reports. I want to skip that as we're wrapping up. The one thing I wanted to show you is remote access to the installation. After the installation, the appliance is running on customer's infrastructure. There's actually no consistent way you can access it. However, if they allow you to create a WebEx, you get a nice way to SSH into the box through the web UI that runs locally with every Telecube installation, that takes the application, packages it with a tarball, runs there, then it starts on the customer's infrastructure in air-gapped mode. It doesn't dial to the internet, but it doesn't mean that you cannot consistently log in here during the debugging session. So Telecube comes in with a built-in remote access tool that can work both in bare metal air-gapped mode and can optionally connect back to your operational center, so you can centralize your access to customers that allow you to. If customer does not allow you to do this, this tool is still helpful. So everything we do here will be recorded, so if your services team member does something on customer infrastructure through the WebEx session, it will still be there. In addition to that, we'll still have this operation log. So your services team can see what actually happened in the cluster. All events happened there will be in audit style displayed here. There's a bunch of other stuff. I want to skip through this access remote and configuration of networking as the more in advanced section, because I wanted to get to really interesting topic that I was not expecting when we started helping customers with on-prem deployments. These is organizational issues are as important as technical ones. And the first one is to set up expectations with customer IT. If you go to your customer, you have to give them the checklist that communicates clearly what they should do before considering this deployment to be production ready. The examples of those things they should do, they should wire up automatic backup, restore procedure that you have implemented, and alert. They should wire up alerts. These are two most important things they should do. If they don't do them, whenever S1 ticket happens, and if they don't have backups, it means that your services teams will be figuring out stuff as it goes, which is not good. Imagine you lost all the disks and there's no backups, and this is a production environment. Customer still expects you to help. It doesn't matter that they forgot to set up backups. They still need your help. So the really good solution with that is to give the example checklist to customer and to equip your services team to go with this checklist with every engagement and make sure all managers on the customer side have this checklist. They see it. Once they have this checklist, they're empowered to use this as an internal tool as well. We'll send you the examples of the checklist after the webinar, so we don't need to go through all the points. The same about system access. It's really important to have a consistent system access to your application. It's important to have an ability to set up SSO when you deploy the application inside the team as well. So you don't have this fragmented deployments on top of your infrastructure. The backups and alerting thing I have mentioned, so that's really important to have. Monitoring and troubleshooting, we went through parts of that as well. Availability expectations, it's really important to tell customer that if one node goes down, your system will continue working. But if 2 nodes out of 3 nodes goes down, the system will not continue working. So that should be a part of the checklist as well. My favorite is called fire drill exercises. Fire drill exercises, basically, your services team goes on site or creates this webinar style or session with a customer, and you try to break your application with them and show them how application behaves during certain outages. This prepares customer to be ready to the case when application failure occurs, like a disk failure. So they're actually empowered to just recycle the node and bring one back. So that's a really important training we have. And the last one, I want to wrap this up with preventing internal team fragmentation. Usually, if you don't unify your deployments across your cloud team and your on-prem team, that's why having something like Kubernetes is really important. You will have 2 teams. One is kind of internally called cool team because they're working on the cutting edge technology, AWS, Google Cloud, Kubernetes, and then there is non-cool team that no one wants to be part of. Basically, if they deploy on-prem with Ansible or something like that, they are in trouble many times. They're often on calls, so no one wants to be part of the team. So the way to solve this team, the fundamental problem that creates a lot of friction in your company, to standardize on Kubernetes across the whole org. And then it will allow you to have this really solid foundation. You'll have just one team called platform team that takes care of all deployments on cloud, on bare metal, and they're all the same. They're all deploying to Kubernetes. That means that you don't have this cool and uncool team. Everyone is now aligned to deploy on Kubernetes. Everyone becomes Kubernetes experts on this core team. And then internally, you can just rotate people, say, hey, you're on-prem duty within my team, within on-prem section of the team for this 2 weeks, and then you go back to the cloud. So you don't have this isolated silos of teams that are constantly disconnected from each other and cannot communicate well. So that constitutes my webinar. I hope it was helpful. We're out of time, but if you have time to ask me questions, I'll stay for a couple of more minutes to answer any questions if you have any. Thanks for listening. I think we have recorded this webinar, and we will also send you the PDF version of this guide through the email list, through the emails you have registered with. So thanks for watching and hope it was helpful.